Hey everyone, today we're going to be looking at a couple of Yamaha REV effects processors, or digital reverberators as Yamaha called them when they came out. So I've got the REV5 here, I've actually got two of them along with the REV7. So these are very similar looking units. They came out kind of sequentially. The 7 is actually the oldest. Well, the REV1 is the oldest, which is a very powerful, very rare effects unit that came out in 1983. After that, the REV7 came out, which was also a very, very good unit. We'll talk about that a little bit more. Followed by the REV5, which was the later one, which came out in 1987. So the REV series was Yamaha's professional series of effects units, compared to like the SPX series, like the SPX 90, which was more of the home use series. These were more expensive. They're bigger, obviously. They've got significantly more DSP, which I will talk about. It's one of the main differences between the SPX series and then the REV7 and then the REV5. And when these came out, they were extremely expensive, but now you can get them pretty cheap, and you can get them really cheap not working, which is good because they are extremely easy to fix in most cases, which I'm going to talk about here. But the weak point with all these units is always the power supply, which is what I'll have to address in all three of these. So I'll be going through the power supply rebuild in this video. And spoiler alert, it's basically the same power supply that's in your SPX 90, so there's not very much difference there. But it is cool looking at these effects processors because they are so much more powerful than the SPX 90 going through there in terms of the DSP and in terms of the actual digital analog conversion in here. So the REV7, as I mentioned, came out in 1985. And it was a 16-bit effects processor at the time. So it's based on Yamaha's YM3804 DSP. This is the same DSP chip that you find in the SPX 90, among a lot of other Yamaha products at the time. That DSP engine that they made, they rolled themselves. They produced their own silicon, for the series of effects processors. So the sample rate on this is only right around 31 kilohertz. So even though it's a 16-bit machine, your maximum frequency range on here was roughly 20 hertz to 12 kilohertz. So not really high frequency. When the REV5 came out, they increased that because they're able to get a little bit better DACs in it. So they went from the PCM53 in the REV7 up to the PCM55 in the REV5, and that gave you a sampling rate of 44.1 kilohertz, basically CD quality. So you get your full 20 hertz to 20 kilohertz frequency range out of it. So much better unit. And the DSP in this is just a monster too. So the YM3804, which I mentioned, is their DSP engine. While the SPX 90 only had one, the REV7 has two. The REV5 has got three of them in there. So later in the video, like I said, I'll probably work on one of the REV5s for this video, but later in the video I'll take apart the REV7 so we can compare it between the two to show the differences in there. Besides that, the REV5 and the REV7 is very similar front panel layout. Each has a parametric EQ that's defeatable right on the front there, and an analog EQ, which is kind of nice. There's digital EQ available in these as well, but this analog EQ is pre-effect, so you can actually just use it as a parametric EQ if you wanted to by bypassing the effects altogether. Then you have a true, I believe it's stereo parametric in here. I might be wrong about that. I'll have to look at the data sheet. So even though these are stereo inputs and stereo outputs, the effects are actually summed as they go through the analog digital circuitry. So it's not true stereo effects on there, even though they do break it out to stereo as the effects leave the unit. So besides that, front layout is pretty much the same between the two, minor little differences in buttons, but they're basically the same. On the back side, they are all roughly the same too. So you've got your MIDI on both the REV5 and the REV7, and then your stereo in and outs, both XLR and then a 1/4 inch. Again, the XLR finding on the higher end gear, which this gear was marketed towards. So as I said, even though we've got to fix all three of these, I'm only going to fix one for this video because the repair is basically going to be the same for all three. With that said, we'll take a look at them too because I've got the service manuals both for the REV5 and the REV7, so we can compare information on them between the two, looking at the actual schematics as well, which would be pretty cool. So I will clear the bench, I'll grab one of the REV5s, and we will start taking a look at it. So here's our REV5, got it on the bench here. I just wanted to power it up and just show what the symptoms of these devices are. So if you can see, I've kind of got a little bit of display there. Power it off, you get some flickering. It's really not doing anything. So it's one of the typical problems you'll see with the REV5, REV7, SPX 90, others of this era that made by Yamaha. You'll see that, what I just showed you here. Secondly, you just see the unit's just dead. You got nothing out of it. You'll see it power on, but it won't pass any audio through it. So those are the things you'll see when the power supply starts going bad. The power supply in these has always been the weak point. I mean, granted, it is 30 years old, over 30 years old at this point, so it's lasted a very, very long time. I know some have failed much earlier than this. It all depends on usage, how many hours it's been on, environment it's been on, etc. like that. But if you have a REV5 or REV7, it's going to be worth going through and rebuilding the power supply, replacing the capacitors in the power supply. So we'll open it up real quick and take a look. So here's the inside of the REV5, and right away, first thing you'll notice, even though I should talk about the power supply, I want to talk about the digital section here, because you see this DSP board with the 3 YM3804s on there. So they couldn't even fit them on the main board. They actually had to have the second daughter board that plugs into the main board to provide all the DSP. With that, you've got all your DRAM. This is the same DRAM you see in the SPX90. These DSP engines will support up to 192K of RAM, I believe it is. So these are, I think, 64 by 4. I'll have to check on it. I know they're 4 bits wide, because combined you've got the 24 bits to actually, it uses 24-bit wide memory for the actual DSP engine. And then over here, I believe it's the YM3608. I believe that's your modulation generator. Again, these DSP engines don't have any way to have built-in modulation for any type of effect, flanger, things like this. So they have a separate chip designed just for basically producing modulation, and all 3 DSP engines are driven off of that modulation generator there. So very cool. I mean, a lot of DSP power in this, especially for the time. So even modern today things, this is pretty considerable DSP going on here. So besides that, in digital board, you've got your battery down here, just a standard 3-volt, lithium. We'll check that, see if it's good. I'll probably replace it. It is soldered in on this unit. It's not a socketed battery. This board over here is primarily your analog and analog digital analog section. You can see the shielding they have here that separates the straight up digital clocking from the more of the analog portion of the signal here. We'll find our DACs. I believe they may be under this board here. I believe there is just one on this unit. It is a stereo DAC. And then our power supply. So very similar board, if not identical, to the power supply in the SPX90. And it's going to be the same supply you see in the REV7. There's minor revisions of it that they made over the years. Japanese models have a little bit different design too than the European models, depending on the input voltage. So these aren't full compatible in terms of being able to just put input 240 volt into a 120 volt unit. There are some minor differences between them. So looking at this power supply, it's pretty obvious. You've got some big bulging caps in here. Caps down there don't look awful, but they're going to be problematic too. And then the other issue is the black goo that they have in there. I'll get a little bit closer angle. So in here they've got this black, it's almost some type of epoxy or silicone or something like that. They put it on the caps just to prevent vibration from wiggling around too much. The problem is as it aged and it gets hot, it becomes very hard, and it actually becomes conductive. So it becomes a problem in here in terms of it can actually short out some components. So I'm going to scrape all that out as I replace capacitors. There's only a handful of electrolytics in here anyway. You've got the 7 in the output section here. You've got your main one for the switching power supply, and that's it really. So replace all the caps. I mean, basically all you have to do is replace all the caps. Check your 5 volt digital. This little pod here adjusts your 5 volt digital. Make sure it's with in spec of the data sheet or the service manual. Might be 5.1 or something that they actually want on there. We'll check it to verify. And that's it. That will solve and get this unit running again. Pretty much every unit out there is just by rebuilding this section of the power supply here. So moving over to the next section, kind of the analog section here, you notice there's a lot of electrolytic caps. I'm not going to count them, but I'd say there's definitely probably 50, 60 on this board, not including the ones up here in this. So we just need to look and see if any of them look problematic. Once the unit's running too, you can obviously do a sound test and kind of verify everything is looking that way on there. Ideally, you really don't want to replace all of these just because it's a lot of work, a lot of time. It can get rather expensive if you're using a high quality cap to do so. We'll still take a close look at them, make sure none are leaking. The REV5 too, being a 2U unit, it's got a lot more airspace inside here, so a little bit more room for convection to happen. And these units these capacitors run a little bit cooler than you do in the SPX90, which is a 1U unit, which when you stack gear on top of it, other hot gear, it can really increase the temperature up in there. So we'll take a close look at those caps. I'm hoping I don't need to replace them, but I may have to do some. we'll find out. A lot of the ones in the audio section too will be non-polarized, so you have to be careful about that if you are going to replace them. But we'll take a little bit more closer look at the digital stuff at the end here, and we'll compare it to the REV7 as I mentioned. For now, we'll start working on the power supply. Being a switching power supply, be careful of this main cap. It can hold a pretty nasty charge. So just always make sure discharge before you do anything. There may be a bleeder resistor in the supply across it to discharge it slowly, but you always want to be careful anyway. So the power cable on these boards has always been soldered to the board. I don't bother removing it. You've got enough room here to be able to work on it without having to desolder those connections. Alright, so the capacitors I'm going to use are made by Panasonic. They're their EEU EB series, 105C rated. I'm using 105C rated caps, through this entire power supply. These have an endurance rating of 105C at 10,000 hours, I believe, so really good quality cap. I like Panasonic's. You're welcome to use whatever you like. Nippon Chemicon, Nishikon, whatever. They're all good brands. I mean, actually in here, these are Nishikons that they used in this device when they built it. So they're only 85C rated though, which I feel is a little under-spec'd for the use, given, it's a professional piece of gear, rack mount, etc. But again, they're good caps, and it's been over 30 years, so they've done their job. When you do replace capacitors in here, I strongly recommend 105C rated caps, and definitely go with a good name brand. See the bulge in that cap there? So there's a bad one. Definitely leaking there. Doesn't look like there's any damage to the board or components though, which is good. A lot of times you'll see the leads starting to rust and corrode, and I'm not seeing that here. Alright, I have the power supply reinstalled. I've got the main power hooked up. It's all screwed down. I got the outputs from the power supply going to the main board here. So this is your 5-volt digital and ground, all 6 of those cables. It's just 3 and 3. And then you've got your 18-volt plus and minus 18-volt on this connector over here for your analog side. And you actually have a couple more regulators in the board here for your DACs and your op amps and things like that on the analog side. So this power supply does require load on it to actually provide correct output voltages. So I'm going to power it up right now. Actually, I'll tilt it up so the camera can see here. And it powers up. And it looks good. Heard the relays click for the delayed turn on, so let's check our voltages. .99. I mean, we're basically right there. I checked the data sheet, or not the data sheet, but the service manual, and it doesn't actually give an exact spec for the voltage other than 5 volts. So just make sure you're right on 5 volts, which I'm there, and you will be good. So just another power up. And that's it. So I've got a display segment out there on my LED display. Huh. I'll have to look at that. So EQ on, EQ off, stereo mono. I hear the relays clicking. Obviously we haven't confirmed it's actually working yet. We got to pass some audio through it, but I have no reason to doubt that it's not going to work. So the REV5, along with the REV7, has a built-in sequence of tests that you can actually run on it to verify operation of basically everything on the unit. And if it passes all these tests, we'll test the CPU, DSP, all that, you'll have good confidence level that everything on it's working. For this, I'm mainly interested in just running the test for the LED display, just to verify that that's actually an out segment before I go tearing the front panel off this thing. So to enter the diagnostic mode, you hold REV1 along with mute, and then power it on. And you'll see you'll end up in this diagnostics menu there. And from there you can load the various tests for the different aspects of what you want to test in the REV5. In this case, to test the LED display, you press, it's program 2. So you press memory, followed by the number 2, followed by enter. So test LED, and it cycles in through. And you can definitely clearly see that the center segment on that display is out. It's going through and testing all my other lights over here too. So everything's gone there. We can test the LCD while we're here. So memory, let's test 1. Well, let's test RAM because I pressed 1 twice. Sure. Memory 1. Recall. So it's verifying the segments. LCD looks good. It's reasonably bright still too, which is nice. The displays they use in these are relatively high quality. Either that or, I mean, these units are really clean too. They may not have had a lot of, use to them. I'm not entirely sure of their history. But we'll run through a couple of other tests here while we're in here. So I completed all the tests. Everything else on this seems to be fine. So I'm going to pull this front panel off because that segment that's out is going to bug me. And I want to get it fixed. So that'll be the next step. Something spilled on that, or what that is. I wonder if that's a problem. It'd be pretty unusual for a single segment in one of those LEDs to go bad. I don't like the corrosion that's on this cable. It's pretty nasty in there and I can't really get to it. So I'm just going to cut this cable off, desolder all the pins out of there, clean it, reassemble it, and see if that's, it may be a broken or something connection in here on one of those leads for that. I'll pull the quick data sheet for this display too to figure out which pin is actually that segment. I'll start there. And if not, I think I have some of these displays sitting around if it's actually bad. I mean, I gotta check the signal coming in too, make sure it's not like a blown driver or something down there, which would be unusual. But I'll start with just cleaning that connector because it's really gross down there. So I cleaned up the bottom connector, resoldered it in, made sure all the connections were good. I still got to clean up the little bit of pins there, but I'm still confused because that segment's still out. So I went through and just verified that the fact that it's not the segment itself. If I bring it over to another pin there, you see that the 2 is good on the middle segment. So looking at this closer, this trace on the top here is corroded. So something must have spilled on this and just got it all nasty because like it was really, really bad down in there. I had to clean. And I'm seeing the top here too. So it doesn't make any sense though because nothing can get in here really. And there's nothing else near it that could have spilled on it. So I'm a little confused as far as what that could be. But regardless, I need to repair this trace that runs across the top. And that will restore the segment that is bad. So I will do that now. So I've got that trace repaired, just a small piece of wire, and let's see, it works. So that's fixed. I can throw it back together now. For anyone that's curious about replacing the LCD on the REV5 and the REV7, it's just a standard Hitachi HD44780 compatible LCD display. So again, you can get any of these off eBay for a couple dollars and replace it if you'd like. Since I have the faceplate all ripped apart, it's always a good time to clean it. Use some good plastic cleaner and soft cloth, microfiber, or something similar. Don't ever use paper towel. Paper towel will actually scratch the clear windows on this stuff. You use microfiber or something else, very, very soft. You don't want to scratch up your windows. Okay, fully reassembled, minus the top. Power it on, and we have our display. So you can see that segment is repaired now. So should be good there. Next thing I want to do is kind of just look on the inside and, like I said, inspect some capacitors, make sure I don't see anything else that looks suspect, and then just talk a little bit about the architecture too, because it is a really neat machine. Alright, so taking a closer look here, there's a few things I've done. I've gone through and kind of inspected all the capacitors throughout this region in the back here. On the SPX90, you would see a lot of the capacitors in the analog circuitry in this little back area start to leak and go bad. I've taken a pretty close look at them, and I can't see any that show any symptoms of leaking all through it, which is good. So I'm definitely at this point not going to start just changing out all the capacitors in this board. I mean, for the most part, you don't have to do this on these REV5s. Like I said, it doesn't get that hot over in this area, which is good. Secondly, there was a bunch of more of the epoxy that had hardened around the two regulators here for your plus and minus 15 volts for your op amps and DACs as well. I scraped all that off, cleaned it all out, because that's going to cause problems eventually too. So I just made sure that I got all traces of it I could get out of there, just as I did in the power supply. Looking at the circuitry, there's a couple DACs on here. So the first one is right here. This is the PCM56 that I mentioned earlier in the video. The PCM56 is a 16-bit DAC serial input, so it's actually serial data that's streaming from the DSP board into this, and then this is actually driving your outputs on the unit. It's going over here a little bit too through your filters and things like this, op amps on the actual output. You have a second DAC over here. This is a Burr Brown, another one, PCM55. So another 16-bit DAC, parallel interface on this one, and this is actually used as part of the analog to digital conversion. So they're doing a sample and hold type technique to do the actual analog digital conversion on here. I've talked about this in my other videos as well. Like every piece of gear around this time did it this way, strictly because good, high quality analog digital converter chips, dedicated ones, were expensive, and this was kind of the preferred way to do it at the time, and it worked very well, and it still is a good method or a good way of doing it today. So digital board we've already talked about, but again, you've got your three Yamaha DSP engines, your YM3804s, along with the RAM bank for each one of them. It's all DRAM. Along the side here, you've got your YM3807, which is the modulation generator. That produces the modulation for all of your DSP, for your flanger and other effects that require modulation. And then the Yamaha YM3608 is part of the digital EQ. So this works along with the DSP for your actual digital side of the EQ. You still have the analog parametric on the front. This just maintains the digital side that's actually part of some of the configuration and presets inside there. So some circuitry underneath this that you can't see because the DSP board takes up so much room is the main CPU. So looking under the DSP, I just flipped the DSP board up over here to see what's underneath, and this is our main CPU. It's a Hitachi HD6303 series CPU. It's 6800 compatible, I believe, 8-bit CPU, and that essentially drives the entire unit. Drives all the logic up here to control the button interfaces and the display driving, and then you've got your ROM here for the actual OS. As far as I know, the REV5 only had one version, version 1.0, for the actual firmware that runs it. I've never seen another version. Correct me if I'm wrong. I would love to know if there were newer versions of the software for this, but I've never seen it. And then you've got some RAM and ROM as well over here for the actual operation of the unit itself. So this chip here, the Yamaha YM3901, that is part of the analog to digital circuitry. It's some type of interface driver that actually drives that DAC. I'm not entirely sure of its role. Again, there's basically zero information out there about it. But looking at the schematic, it connects directly basically to, you can see the lines connecting to the DAC right there. And then it talks a lot, both to the DSP and to the microprocessor on this side across, the data and address lines. That's really it for the digital side. Last thing I want to check was just that battery. I looked underneath it, and it had been replaced before. So I don't know how long ago, but I'm betting that's going to be fine right now. So we'll just give it a test. 3.1. So we're fine. It's good. I'm not going to bother replacing it right now. If you do need to replace it, that's where it is. It's simple. And something else really nice about the REV5, along with any well-designed piece of gear that's designed to be serviceable, is that the bottom actually comes off. I didn't show this before, but the whole bottom comes off that gives you access to the bottom of the board, which makes repairing and working on it really easy. You can actually get to the power supply from here too, but I choose usually just to remove the whole power supply because it just gives you easier access to it versus trying to dig down in there to get all the capacitors out. So that kind of sums up the REV5. I'm going to throw this back together and just give it a test, make sure everything is working okay. Just because I was curious, this is my second REV5, the one I have not worked on yet, and taking a look at the power supply here. Doesn't look as bad as the one I just did. It's definitely got the black gunk in there that's all dried. That one's not as bulged, so I'll have to recap this one as well. Other than that, it looks pretty much identical. I didn't check serial numbers. I'm not sure which of the two is newer than the other one. And here is inside the REV7. So it is different, as you can tell. Lots of little things. Power supply, slightly different revision. Ultimately the exact same outputs though. And they're all pretty much, like I said, interchangeable between the SPX90, REV5, REV7. They all use the same power supply, same output, same connector, same voltages. So just a couple different revisions of that supply. This one being a little bit older. Analog section, different as well. So you've got the two PCM53 DACs in here. One is actually used for the digital to analog conversion for your outputs. The second one is used for the analog to digital conversion for the sample and hold circuitry, much like the REV5. Filtering is different over here. We got a different style, filter for the outputs. Your two 15-volt regulars, plus and minus right there, exist still. Besides that, just a lot less components. But this is a lower spec unit, so you would expect to see that. Digital side, similar but different. So you've got the same processor, the HD6303, I believe that's the same. Your RAM is REV7, version 1.0 right there. Again, with your RAM and for the actual CPU. Here's your YM3807, that's your modulation generator. And in this, you notice we don't have that daughter board, we've got the two YM3804s, but there is two of them in here, compared to the SPX90, which only has one. And then your RAM bank for each of those, the DRAM is sitting right there in front of them. So a lot less, a little bit busier on this board, but again, they couldn't fit three of these on this board for the REV5. That's why they had that second daughter board, in place there. So this one, same problem. It actually even has a note on the cover. No power, problem unknown, fuse good. Well, problem is known, it's a power supply. So I will repair this one as well as the other REV5. Okay, have the REV5 hooked up real quick, just feeding it from my Alesis QS8 and going through my mixer to some monitors here. And it works. So a little bit more, make it a little bit wet there, but so it works. You only have a handful of algorithms on this unit. So you've got your large Hall, small Hall, focal plate, progression plates, your plates, and then your early reflections. The REV5 was really known for these two algorithms specifically. Besides that, under others, you've got, a lot more. I forget exactly how many this unit has, 30, 40, 50, somewhere in that range, of just various different mixtures of those algorithms with some EQ, with some modulation, things like that. So, while it is a kind of a multi-effects processor, its strength was really reverb. Although a lot of people do like a lot of the other, presets that are on here. And it's fully controllable too. I mean, with each preset you can go through the different parameters and actually, adjust various aspects of them, in terms of reverb time and everything else, along with them. So, they are powerful in terms of tweaking as well, and to, tuning them and getting them to, the reverb to sound how you want it to sound. So that pretty much sums up the REV5 and the REV7. Power supplies are the main cause of any issues you're going to have with them, and it's a super simple repair. So very cool effects processors. If you have one that has failed, or you can find a broken one, they're easy to fix, and I would definitely recommend doing. They're still kind of a sought-after effects unit. So Thank you for watching.